Assalamualaikum and hi everyone. Today we are going to continue our lesson on the topic of equation of planes. The learning outcomes of today's lesson is to determine the equation of a plane in the space. Now we look at an equation of a plane. Let's say we have a plane P which have a vector perpendicular to it as vector normal vector n, A, B, C. And also we have a point on the plane as point P naught, that is x naught, y naught, z naught, and also an arbitrary point P, x, y, z. Okay, and it is given by this figure. Okay, if you look at here, we have this is a plane P. We have a vector normal to the plane as n, A, B, C, and we have a point on the plane P, x naught, P naught, x naught, y naught, z naught, and we can also have a point, arbitrary point on the plane P, x, y, z. Okay, we can also have a vector P naught P. We can find the vector P naught P. Okay, is equal as x minus x naught, y minus y naught, z minus z naught. That is vector P naught P. Alright, so if you look at here, um, n and vector P naught P, they are both perpendicular, right? They are perpendicular. So therefore, if the two vectors are perpendicular, the dot product between the two vectors, it is equal to 0. So that's why we get vector norm n dot product with P naught P is equal to 0. And after that, we replace n with vector ABC and P naught P, x minus x naught, y minus y naught, z minus z naught equal to 0. Okay. And after that, after we simplify, we will get the uh, equation of a plane as ax plus by plus cz minus ax naught minus by naught plus cz minus cz naught is equal to 0. Okay, so this is the equation of a plane. Okay, given vector normal to it ABC and a point on the plane as x naught, y naught, z naught. Alright, now we go to the first example. Okay, where we are going to find the equation of a plane passing through points 3, negative 1, 2, and the plane is normal to vector 1, 3, negative 4. Okay, this is the figure. Okay, shows the situation. The vector normal is 1, 3, negative 4, and the point on the plane is 3, negative 1, 2. Right? So we will use the equation of the plane, okay, based on the previous slide. This is the formula that we need to use. A, B, and C comes from the vector normal to the plane, and x naught, y naught, z naught is the vector point on the plane. So therefore, towards the end, after we expand it, we get the equation of the plane as x plus 3y minus 4z plus 8 is equal to 0. Okay, this is the second example where we are going to find the equation of a plane passing through 3 points, point A, B, and C. Okay, so this is the situation of the plane, okay, with 3 points on it. Alright, so we can also have a vector. Let's say we can find the vector AC and vector BC here. Alright, so if you look at here, we have a vector AB as negative 1, negative 5, 1. Vector AC as 1, 2, 0. So as we have discussed in the previous slide, if you want to find the equation of the plane, we need to have the normal vector to the plane. So what is actually the vector normal to the plane? So if you still remember, okay, when we discussed on the cross product last time, alright, so if the two vectors, okay, we do the cross product, the two vectors, we will get a vector normal to it. So therefore, if we do the cross product between AC and BC, alright, we will get a vector normal to AC and BC. It means also a vector normal to the plane, alright. So therefore, the normal vector of the plane would be given as AB cross AC. Okay, and after we calculate, we get it as negative 1, negative 2, 1, 3. Okay, that is vector normal, negative 2, 1, 3. Alright, now we want to find the equation of the plane. Alright, so we already have use this formula. Alright, ax minus x naught plus by minus y naught plus cz minus z naught equal to 0. And after we replace A, B, and C and x naught, y naught, z naught, alright, so towards the end, we will get the equation of the plane as negative 2x plus y plus 3z minus 1 equal to 0. Okay, now we look at example 3. Okay, example 3. In example 3, we want to find the point of intersection between a line and a plane, right? So line L is given with the parametric equation, this one, and plane, this is the equation of the plane. Alright, so this is the figure which shows the situation of that. Alright, we have a plane with, we have a line, okay, passes to the plane, and we can see that if we have a line passes through the plane, it intersect at one point here, and this is the point that we are going to find, right? So we have equation of the line here and equation of the plane. Okay, if we substitute the equation, the x in the line in the equation of the plane, so x replaced with 2 minus t, y will replace with negative 2 minus 4t, z will replace with 2t, okay, in this equation. So towards the end, okay, we will get that t is equal to negative 1. Alright, so at t is equal to negative 1, okay, we substitute in here in the equation of the parametric, we get x is equal to 3, y is equal to 1, and z is equal to negative 2. So therefore, the intersection point of the plane and the line is 3, 1, negative 2. Okay, and it shows here. Okay, this is the point that we have already calculated. Okay, now we have two exercises. Okay, so we this is the first exercises where you need to find the equation of the plane. We have 11 questions here. Okay, with different situation. And this is the exercises 2. Okay, we want to find the point of intersection between line and given plane. Okay, you can try these exercises at home, and we will discuss it in the next lesson. Okay, that's all for today.